Number question 3 and number 4. A stone of mass 59 gram is thrown horizontally from the top of cliff with speed of 18 meter second minus 1 as illustrated in figure 4.1. Ini Bapak sengaja ambil yang projectile motion ya. Sebenarnya yang lainnya kinematics ya. Ada juga yang di luar projectile motion. Jadi karena topik kita adalah still in projectile motion, so we will solve some question about projectile motion. 18 meter per second horizontally, and they have a height as 16 meter ya from the sea level. The initial height from the stone level sea is 16 meter. Yeah, air resistance may be neglected. State the horizontal velocity of the stone as it hits on the water. Okay, this is constant ya in apa namanya horizontal velocity. So it's been same thing yeah, with 18 again. This is 18 meter per second. Yeah. In every single point, yeah, the horizontal velocity is same. Okay. Then kok ACD? Oh, kenapa ini ACD? Okay. On the grid figure 4.1, draw a vector diagram represent the horizontal, vertical, and resultant velocity of the sound as it hits on the water. Okay. This horizontal velocity, same length with this one. Ini sama panjangnya, kira-kira kalau begini. Maybe like this. So when we get the trace force, trace-nya kayak gini misalkan. Let's say sampai sinilah. So horizontal this is trace ya. Every single point is same. This. And what about horizontal velocity? Because they asked me about resultant velocity. Yeah. Resultant velocity. So in this point is 0, but in this point, this is like they have velocity. And also in this point, they have like adding some velocity. And then on this side also more length. So resultant of velocity is when we have like let's say like so resultant velocity, I give the red one. And then in this position, also the red one is resultant velocity. And also in this position. So the red one is resultant velocity. Okay, that's it. When we put, this is 18 meter per second. Yeah. This is also 18. This is also 18. Yeah. But what about on the vertical? On the vertical, they have GT. Yeah. This is like GT. Let's say GT1. Yeah, G times T1. Yeah. And also G times T2. Yeah. And then maybe here GT T3. Yeah. After hits the sea level. Yeah, that's it. Ya, coba we try to draw it. Ya, kalau kita copy paste from this, ya. Let's select this one, ya. So they have initial velocity as 18 here. This is 18, yeah. And every point is same. Yeah. Yeah. Then they have also on the other direction, yeah. This more length and this more length. Yeah. So when we talk me about use your vector diagram to determine the angle with horizontal at the which the stone hits water. Yeah, maybe we use both tangent. Yeah. Tangent. We have 18, yeah, on the horizontal speed, yeah. And then we have 16 meter, yeah. So maybe we can use 16 and 18 to find other other velocity. Yeah. So when we know h equals to VOT, yeah, plus a half GT square. Yeah. And we know this is about 16. And VO on the vertical direction is 0 times T also, we don't know, but T, yeah, plus a half T is 9.8 and T square. So we get T, this is about, let me take calculator first, yeah. This is like 16 times 2 divided 9.8. And then we root it here, 3.2. And we root it. Oh, this is about 1.8. Yeah, 1.8 second. So we will find our velocity when they have hits the sea level. Yeah, V equals to VO, yeah, plus GT, and then this is V on the Y, yeah? Vy, so VO is 0 on the vertical direction, G is 9.8, and then T is 1.8. So Vy equals to times G. This is about 17.7. Yeah. 17.7. 17.7 meter per second. Okay, this is Vy. Yeah. Then after that we can get about theta. Yeah. Here. Tangent theta. Yeah. Tangent theta is Vy divided by Vx. Yeah. V horizontal. Tangent means Vy is 17.7 and then Vx is 18. So tangent, yeah, 18, 0.98. Tangent theta is 0.98. So theta, yeah, is we use tangent minus 1. Oh, 44. Yeah, oh, around 44.5. Maybe around 45 degree. Yeah. Yes, this. So I get 45 degree. Yeah, here. 45 degree. Seperti itu.
Oh, boleh naik bentar? Aku mau lihat hitungan.
Boleh, bentar. Yeah, question 8. Distinguish between scalar quantities and vector quantities. Oh, yeah. Scalar quantities, they don't have direction. Yeah, vector quantities, they have direction. Yeah, direction and magnitude. ya. Scalar has only magnitude. Kalau boleh Bapak tulis gini. For scalar, they has only magnitude. Hanya memiliki besarnya saja. And vector has magnitude and direction. Yeah, this is distinguish between scalar quantities and vector quantities. Then continue B question. Yeah. In the following list, underline all the scalar quantities. Scalar, yeah. Okay, scalar has no magnitude. Acceleration have, yeah. Force also. Kinetic, yeah. This kinetic, because the energy, they don't have any direction. Yeah. This is also, this is power also. Yeah. Weight they have, yeah. Weight same thing with force, yeah. Weight same thing with force. Okay, now but see. A stone is thrown with horizontal velocity in 20 meter second minus 1 from the top of cliff 15 meter height. The path of stones on figure 1.1. Okay, this is I think same thing with previous number, yeah, but different magnitude. Air resistance is negligible. Okay. For this stone, calculate the time to fall 15 meter. Oh, okay. Let we start from 8, yeah, 8. And they don't have any velocity as a vertical motion, as on the vertical direction. Yeah. So h equals to v initially vo times t, yeah, half gt square. So they have falls as 15 meter high, and they don't have any velocity on the vertical direction times t. Yeah, we don't know about t. Then a half g, we use 9.8, and t, yeah, we find about t first. T langsung saja kita pakai calculator. 15 times 2 is 30. Yeah, 30 divided by 9.8. And then equals to 3.06, and we root it 1.74. 1.74 second. Yeah. Then after that, oh, done. Yeah, this is about time. Yeah. Oh, yeah. So this here is 1.74. Oh my God. 1.74. Yeah, that's it. I continue. Yeah, I continue resultant force, resultant velocity. So here, calculate the magnitude of result after falling 15 meter. Okay. Now we find about v on the vertical direction. Yeah, as we call it as the vy. Yeah. Vy, yeah, vy. This is equals to vo plus gt. Yeah. Vy equals to vo is 0. Yeah. plus G is 9.8, and then time taken 1.7. Yeah, let's say 1.7. So Vy equals to 17.1. Yeah, let's say 17, yeah, meter per second. We wrote it about 17. Then we calculate about resultant. Yeah, resultant velocity. It's mean because they like Pythagoras. Yeah, Pythagorean. Yeah. This is Vx and Vy. Yeah, Vy like on the vertical direction. Yeah. So we have Vx is 20. Yeah, Vx is 20 meter per second on the x direction. Yeah. This is 20 meter per second. And on the y, on the vertical direction is we have 17 meter per second. So resultant, yeah, as Pythagoras, yeah, of this. So kalau Bapak tulis, nah ini resultantnya ya, kita gambar. So V, ya, V likes gini, Vx square, ya, Vx square, Vy square, ya, and then we root it, ya, power minus half, power a half. So V equals to 20 square, 20 square plus 17 square. And then, so kita langsung hitung saja 20 kuadrat ditambah 17 equals 689 and we root 689, 26.2. This is about 26, yeah, 26.2 meter per second. Yes, that's it. Yeah. So here 26 point 26.2 meter per second. Okay, continue to one more question. Yeah, question I3. Describe the difference between displacement of the stone and the distance that it travels. Okay, displacement and distance. Yeah. Distance, yeah, is the actual path traveled. Ya. Kalau kita lihat distance itu distance is the actual path travel. Ya, jadi kalau ini seperti ini, distance yang dari position this position until this position traveled on this curve, ya, this is distance. But displacement, yeah, this is different. Yeah, displacement is like straight line, you know, before and after. Displacement is, yeah, what we call it, yeah, the straight line distance, yeah, the straight line distance, yeah, between start to finish, yeah, start and finish, start and finish points, yeah, dari titik awal dan akhir, ya, start and finish point. If we see, this is like a straight line, ya. Nah, gini, dari awal sampai akhir, ya, berapa panjangnya? This is displacement, ya. How much distance is when we use straight line before between start and finish? How much length is? Yeah, that's it. Or actually, this in this case like minimum distance, yeah, in that direction, yeah, in that direction as the minimum distance, yeah. Yeah, that's it. Yeah, this is difference between displacement and distance, yeah, that's it.